Hi there, how are you? Welcome to Bats for Data Science. This is Vivek. In this video, we will learn a new Python module, which is Polaris, which is same as Pandas, but Polaris is way faster than Pandas. So to install the Polaris first, you have to do a pip install Polaris. If you are doing it from Jupyter Notebook, you do exclamation mark pip install Polaris, and it will install the required library. I have already installed, that's why I'm getting this message. So let us import the Polaris and Pandas first. And first thing, during the start, I told Polaris Polaris is way faster than the Pandas. Let us see. So in Jupyter Notebook, we have a magic method which is time it. So it runs the entire cell and give us the time taken to execute. So it does not execute only once, but it executes multiple times to see the variation also. Let me execute and show it to you what exactly I mean. So if you see here, it shows that 71.5 milliseconds it has taken to load this particular data, but there is chances that there is a variation of 3.34 milliseconds per loop. So here it has run only one loop, and same thing if I run with the pandas. Let us see how much time it takes. So it's taking 1.25 seconds plus or minus 39.3 millisecond variation per loop. So if we calculate this, if you see the performance, you can see the Polaris is 94% more faster when compared to the Pandas. Just do the calculation, you understand when I say 94%. Let us see how we create a data frame in Polaris. The way we have data frame method in Pandas, the same way we have the data frame method in Polaris. And we use the same approach which we use in the Pandas to create a data frame. So here we have used a dictionary the same way we used in pandas. Let me execute and show you the output. So based on the output, if we see there is a small change in the output. In pandas, it does not show the data types, but in Polaris it does. And it does show the shape also when you print a data frame. You have an inbuilt attribute which is called df.shape to get the shape explicitly from the data frame. So before moving further, let us see how we can import the data from CSV file. So we use PL. So we have given the Polaris alias name as a PL. So here, if you check it here, I imported Polaris as PL and Pandas as PD. So I'm saying ps.readCSV. So this CSV method is same method or similar method which we have already learned in Pandas. So here I am just passing the file path and I'm importing it. So let me import. And so we have done the importing. Now suppose I would like to display that particular data. So by default you can see it is showing a number of columns. But if you scroll further, you can see certain columns are truncated. Here you can see. So there are three dots. It means certain column exists between this and this column, which is not shown because the Polaris has a default setting of n columns to display in the output. So that can be changed using config set table rows columns methods available in Polaris. So if I say 100, it means if I directly print a Polaris data frame, if I set this thing, it means it will show the 100 rows. And here, if you see, I set the columns as 5. So let me execute the Polaris data frame again. Now you can see it has shown only 5 columns. And this last one, set FMT format full. It means any number which is presented in a scientific notation will be converted into normal notation. So that's how these three we have already run in pandas. The only difference is the way we set in the pandas using the set option, but here we use a config. In config we use a set table rows columns and these particular methods to set that. So that's a major difference. Moving to the next part. Now we have the head method in pandas, same way we have head method in Polaris. If you do head 10, it will display top 10. And so if I don't do head 10 and default, you see we will get a 5 data points. And we have the tail also. Let me show you that. Tail method also. If you do tail, it will show you the last 5 data points. The next is you have the describe method in Pandas, same way you have in Polaris also. If I run describe on Polaris data frame, you can see we got an output here. But when you compare the output, there's a small catch. So Pandas run this describe method only on the numerical columns. But here, if you see, Polaris has run this method on each and every column, though it's a string or not a string or a numerical, it has run on all the columns. So let me show it as we have the data frame. Let me import Pandas data frame also and show it to you. So it would be easy to compare. So describe. Okay, let me add one more cell. Describe. Now here you can see only the numerical columns are taken. There is a 4 numerical columns and it has applied that basic statistics, which is count, median, standard deviation, minimum, max, and percentiles. But in this case, in Polaris, it is applied the describe method on all the columns. That's a major difference between the describe of Pandas and describe of Polaris. Now moving to the next part. So we have seen in Pandas that we have a columns attribute available, which will display the list of the columns. Same way here in Polaris, we can get it. So this is the similarity. And next thing is we have renamed certain columns in Pandas. Can we do here? Yes, we can do here, and we have a method called rename to rename the columns. The same approach we have followed. We have passed a dictionary with the column name and the new name we would like to give it. So if I run, and now let me print it. The DF Polaris. Now you can see the columns are renamed. Here you can see Pola rename 1, Pola rename 2. The same way we can rename it. So even the renaming is pretty much easy or similar to Pandas. And the next thing is how you can access the data points in Polaris. So in Pandas you can give an index, and you can access it. Same way you can do it here. So if I say Polaris 0, it is giving me the first line item from the data frame. The second is I would like to access, suppose, so for survey is I would like to extract the data point from the first row. So that you can achieve using this approach where you are passing the index, comma, and column name. So NA. So the value of survey is at 0th row or the first row is NA. So that value we received. So you can access in this way. The third way, if you would like to access, if you would like to filter only couple of columns to get data from, that you can do. So you can pass a list here with the column names and you can get the output. The next method is a new method which is only available in Polaris. You can use a select method here. If you do a select and a star, it will extract all the columns you have in that particular data frame. Here, if you see, certain part is truncated because I have set max column to display is 5. That's why. Next approach, in the select you can pass the column names. Here survey is and converted com total, and it will display only those 2 columns. And next, the same thing, but here Polaris has an inbuilt method which is call, which is nothing but the column. So pl.call, and then you give the column name. And this way also you can extract the desired column names. So if someone has already learned or learning the PySpark, you can see a lot of similarities between the Polaris and PySpark way of coding. So whoever is learning this thing, he will be at ease when learning the PySpark also. So moving to the next part now. In pandas, we have applied a function on each and every data elements. Can we do that here? Yes, we can do that using the map elements method. Previously, we had applied method same as pandas, but it is deprecated. And now the new method is map elements. If you run the map elements on this survey is the same way we did in pandas, you will get an output where you see the length of each data for that particular column. The next thing is, if you remember in pandas, we have created a custom method and then we applied on each element. Can we do here? Yes, we can do here. The same method which we have used in pandas, same method I have taken here, and now I'm applying using a map element. I did so and I got the required output. The next thing is create a copy of the Polaris. So in pandas I've shown you if there is a data frame called df1 and if I do df2 equal to df1, both the variables just represent or does point to the same object, and when we do changes in the df2, the same changes will reflect in df1. That I have told in pandas and I've shown you also. Same thing happens here if you so first let me show you the idea of a df polaris, and instead of clone I will tell you what exactly clone here is. If I say df2 equal to and print its id, df2 id, you can see both possesses the same id. It means any changes done in the df2 will reflect in df underscore polaris. But if I use the clone method, you can see the id is different for id polaris and df2. So here the clone is nothing but the copy method we have in pandas. Now can we sort the data? Yes, you can sort the data. In pandas we have a sort values method. Here we have a sort method where you can sort the entire data. So here I've sorted the data. The next thing is replace the data. So here when you are replacing the data or creating a new column, the same though in pandas you can write something like this and a new column is created, but in polaris it's not the way. So let me execute this particular part and show to you that it will throw us the error. Yeah, it will throw us the error because polaris does not support this way of creating new column, but you can use with columns method to achieve that. Now here simply I am replacing the NAs with 0. So let me execute, and in the following example we will see creating a new column with this method, with columns method. So now before going to that, uh, in the output if you see this particular data frame, uh, specifically this particular column, you can see the data type of this particular column is string. It means I have to convert it into the number. So I have to do typecasting. For that thing, we have the cast method available in Polaris. Here in the cast, I'm passing a dictionary. So here you can pass the multiple columns. So here in my situation, I would like to typecast only this particular column. That's why I passed it. But if you have more columns, you can say comma, then you pass a column name, and then the the data type you would like to cast to. So now I have casted it to float 32. So let me execute and show it here that it is changed. Now you can see, now see the data is F32, that is a float 32-bit long. So here in the next cell, I am creating a new column. And this column, I'm naming it as a test. I'm giving alias name as test. And I'm saying divide the comp total with 100. And whatever output you has, create a new column and name it as a test. In this particular code, I'm saying with columns, means with all the existing column, take this particular column, divide by 100 and create an alias name, and the alias name is test. So let me execute this thing. Now this is executed successfully, but if I do like, if I do the way I do in Panda, suppose I'm creating a column test2 equal to something like this, it will throw me there. Comp total divided by 100. This type of column creation works in Pandas, but not in Polaris. So we have to make sure that whenever we are creating a new columns, use a with columns method to create a new columns in the existing data frame. So now let me see the output of it. We have divided by 100, and this is the output we got it with a new column. The next part is, can we count the null values? Yes, we can count the null values. For that thing, you use a null underscore count method available in Polaris. So here, if you see for these columns which are displayed here, there are 0 null values available here. The next and the most important thing is, can we do a group by? Yes, you can do a group by using, sorry. So you can do a group by to same group by method which is in Pandas. Similar method we uses here, and here we have passed the column names on which we have to do group by, and now we are applying the aggregation function. And here aggregation function I'm applying on a comp total column, and I'm saying you have to sum it. And if I do so, and if I get the output, now you can see the output, a column comp total. I, instead of this, I can do mean also. Now this is the mean value. So this is how you work with Polaris, and you can see a lot of similarities between Polaris and Pandas, but there are dissimilarities also. And I prefer using Polaris over Pandas because the Polaris is very fast when compared to Pandas. It means the processing time taken by Polaris is very less when compared to Pandas. So you said, okay, Vivek, that's fine. Pandas is very fast, but for certain methods, I'm very comfortable using in Pandas. So can I do? Can we have some work around there? Yes, we do have. Polaris provides an option to convert Polaris data frame into Pandas and Pandas data frame into Polaris. For that thing, suppose we have a DF2, which is a Polaris data frame. Let me show it to you. So here you can say it's a Polaris data frame. So I can convert it into Pandas. So for that, we have an inbuilt method called Pandas, two Pandas. And if I convert into this thing, now you can see this is converted into Pandas data frame. So let me say Panda, and let me run one command which is describe or info, because info does not exist in Polaris. Now you can see the info command is working here. It means this, and here you can see it is in the Pandas data frame. It is converted to Pandas. And now you can say, can we convert it back to the Polaris? Yes, you can do. So for that thing, we have an inbuilt method in Polaris, pl dot from Pandas. And here our data frame is panned. So let me copy it properly. Copy and do. Now you can see it is converted again to Polaris data frame. So though you feel comfortable with Pandas in certain situations, you can convert your Polaris into Pandas, do the processing, and then you again convert back to Polaris. So that feasibility we have. So this is end of this particular video. I would recommend you to go to the description section for coding exercises. We will meet in the next video. Till then, I am Vivek signing off. Bye bye.